An observational study is observing some individuals and measures some variables, but does not influence the outcome whatsoever. In an experiment, you do something called a treatment to a group or individuals, and then observe what happens. Usually it's because you're trying to figure out cause and effect. Although we never in statistics say something causes something else. You could say there's a very strong association. We never use the word cause, even though you're trying to figure that out. A lurking variable is a variable that's not among the explanatory or response variables, but might influence the responses. A confounding variable is when two variables, both explanatory and lurking, so both things that are the independent variables, are associated in a way that their effects cannot be distinguished from each other. And that's why they call that lurking variable confounding. So confounding is a subset of lurking. For example, does eating dinner with families improve their academic performance? According to ABC News, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey done at Columbia University. So was this observational or an experiment?
Observational.
Observational. You didn't do anything to them, you just watched and saw what happened. So this is observational. No students were assigned a particular number of meals. Explanatory and response in this case. So the explanatory would be the number of meals. And then the response would be their grades. Did they talk about GPA or just grades?
Just grades.
Okay. Why is this study not able to establish a cause and effect relationship? For example, is there a lurking variable that might be confounding? So one of the things is, the reason it might not be able to establish cause and effect is there may, as inferred in the statement there, there may be a lurking variable. For example, families that eat dinner together may have parents that are more interested in their kids' academic success and may be helping them with schoolwork. So in experiments, there are certain vocabulary things you need to know. An experimental unit is the smallest collection of individuals which your treatments are applying. So you could do it to every single person in here, or I could select males and females and talk about it that way. Your subjects are when the experimental units are people, so they call them subjects. A treatment is a condition that's applied to those individuals. A factor is the explanatory variable, which we know we call X. The level is when experiments study the joint effects of several factors, and each treatment is formed by combining a value for each of these factors, and you'll kind of see what that means in the context of a problem. So down below here, we're going to talk about the explanatory and response variables, and then we'll talk about the treatments. So in this example, a nutritionist wants to study the effects of combining a good diet and solid exercise program in trying to determine the best weight loss program for people who are considered obese. The nutritionist wants to study two different kinds of groups. One that includes a certain diet, and then there's a second diet, so that's what the D1 and D2 mean. And then three types of exercise problems, which we're going to call E1, E2, and E3. And then at the end, each person's weight loss will be recorded. So first of all, the explanatory variable is the diet and exercise. And then the response variable would be the weight loss. And the treatments, if you look at how many there are in each case, how many different kinds of things that we're talking about the diets, and we're also talking about the exercise programs. So all you do is you list all the different possible combinations of those two things. So for the treatments, there are 6 of them. You could have D1 and E1. You could have D1 and E2. You could have D1 and E3. You could have D2 and E1, D2 and E2, and you could have D2 and E3. And these different possibilities would where you'd be want to select the treatments from to see what's happening with each of those separate subgroups. So in the part A, which I didn't do, the experimental units are the, let's see here, the people who are considered obese. And specifically, did I spell that right? I don't know. E-S-E. And specifically, we'd probably call them subjects because they're human beings. In our part B, probably the fastest thing that you can come up with are the explanatory and response variables. So for the explanatory, in this particular example, you'd be talking about whether you use fertilizer or not. And then, what was the other thing that was going on? Water, thank you. The water. And then the response is the weight. The weight of the tomato plants. Tomatoes. And just like the previous one, it looks like we could do a total of 6 different treatments. So if I'm looking at my treatments, we could have fertilizer and half a gallon. We could have fertilizer and 1 gallon, and fertilizer and 1.5 gallons. We could have no fertilizer. And a half gallon. We could have no fertilizer and 1 gallon. And we could have no fertilizer and 1.5 gallons. And then the experimental units in this thing will be the tomato plants. So when you're doing an experiment,